Hey, we've all seen it in Star Trek. The ship's engines hum, space warps, and the crew reaches another star system in hours. For a long time, this was pure fantasy because Einstein's laws tell us that nothing can travel faster than the speed of light. But in 1994, physicist Miguel Alcubierre found a loophole in the math. This is the Alcubierre drive, the real-world blueprint for a warp drive. Moving space, not the ship. The genius of the Alcubierre drive is that it doesn't actually break the universal speed limit. According to general relativity, while matter cannot travel through space faster than light, space itself can expand or contract at any speed it wants. The drive works by creating a warp bubble around the spacecraft. It would contract space in front of the ship, expand space behind the ship. The ship sits in a flat patch of space inside the bubble, like a surfer riding a wave. The ship isn't moving through space at all. The space under it is moving. Because of this, the crew wouldn't feel any g-forces, and time inside the bubble would pass at the same rate as on Earth. The fuel problem, exotic matter. So why aren't we visiting Proxima Centauri yet? The catch is what's required to create that bubble. To expand space behind the ship, you need something with negative energy density. In physics, we call this exotic matter. Unlike normal matter, which has mass and pulls things in with gravity, exotic matter would have negative mass and push space away. While we've seen tiny versions of this in laboratory settings, the Casimir effect, we currently have no way to create or harvest the massive amounts needed to power a starship. How much power? When Alcubierre first published his paper, the math suggested you would need the energy equivalent of the entire mass of Jupiter to move a small ship. However, more recent tweaks to the math by NASA engineers suggest that if you oscillate the intensity of the warp bubble or change its shape to a donut, you might only need the energy of a few hundred kilograms, about the size of a Voyager probe. The hazards of warp travel. Even if we solve the energy problem, flying a warp drive is dangerous. The horizon problem. Once you are inside the bubble, light from outside can't reach you. This means the pilot might be blind and unable to steer or stop the ship. The particle cannon. As the bubble moves, it sweeps up high-energy particles from space. When the ship arrives at its destination and the bubble is turned off, all those particles would be released in a massive forward-facing blast of radiation that could vaporize anything in front of it. The Alcubierre drive is the ultimate bridge between science fiction and science fact. It shows us that while the universe has strict laws, it also has backdoors that might one day let us leap across the galaxy. Pretty wild, right?